I want to tell you about this one next that helps with performance or understanding the performance more specifically of your code. So I don't know how much profiling you guys do at your work. How much does performance matter to you guys?
It matters a lot.
Yeah.
Yeah. Yeah. People are running. Okay. So I'm building things that go into testing in a production line. So every millisecond that it takes it a millisecond longer to get something shipped. So yes, it matters.
Yeah, it matters. I'm supposed to mostly spend my time on the web, and obviously it matters there, right? Like every 100 milliseconds, I think Amazon measured is like 1% loss of orders or something ridiculous like that, right? Like, so yes. Understanding your performance is good. We've had good in quotes, profilers for Python, and they typically tell you about this function spent this much time. But another challenge is my program is using too much memory, or worse, it's something long running like a web app or some background process, and it's like growing. And it's like sort of leaking memory. Why is that? So I came across this project called Scalene, which is a high performance and high precision CPU and memory profiler for Python.
Cool.
Yeah. So it lets you either analyze CPU time, or it actually lets you on a line by line basis say, here's some memory, what line made this and where is it coming from? Yeah. And so that's cool. But one of the challenges for profiling is when you're profiling your code, you can make it, you don't get the same behavior. It's sort of like the Heisenberg uncertainty principle, right? It does one thing, but when you measure with a profiler, you've changed it. So now you kind of got to say, well, that part where it was the network, that was 50%, but now you made the computational bits way slower. So that network part looks just like 20, right? Like you're affecting it. So for example, like if you use profile, the built-in profile, it can make your code 30 times faster for a simple scenario than running it normally. But you can use C profile, which is the C-based one that's built in. It only slows it down by 1.65 times. So that's not too bad. There's a line profiler that's 11 times slower. And there's a whole bunch of other ones. There's a memory profiler that's like over 1,000 times slower. So the scaling thing has a nice comparison to all these things. It says, well, how does scaling do? And it claims that it's got this built-in library that's much faster. So for CPU stuff, it's 1.04 times the speed. So like 4% slower. And it does that through sampling, right? It doesn't do instrumentation. It doesn't rewrite the stuff. It actually just asks frequently, like, hey, where are you in the code? But it still gets per line analysis of that, which is pretty cool. And then the memory one is like another 10% slower because, analyzing memory is hard. But yeah, there's all sorts of cool stuff you can do with it. The overhead is not too bad. The precision is pretty good. So like I said, it gives you like line by line level of how much time you're spending in various places. It also is interesting in that it separates out the time spent running Python code from native code, including like the base libraries and stuff. So you can say, like, I can only affect the Python stuff. The other stuff is not a thing I can deal with. So yeah, don't tell me about it or punish me for it. Or maybe I do want to look at it, right? Tell me about that. So that's pretty cool. Yeah. And then also the memory stuff I think is pretty cool. So it says it points to specific lines of code responsible for memory growth. And it's important it does this through a special memory allocator thing that comes with it. And so while you can pip install Scalene, you can't do memory. You can't inspect the memory allocation that way. You have to go and install it directly and do some more setup. On macOS, you can do brew install. There's instructions in there on how to do that. On other OSs, I have no idea what you do. But you can't run the memory allocation directly. You have to. You can't just say pip install it and then do the memory allocator. There's something other like lower subsystem that has to get installed for that to work.
Yeah, and memory is an interesting one because it's a difficult one to chase down with Python.
Yeah, so. It's very hard in Python because everything is a pointer. Everything is an indirection. It's not like, well, here's the block where we allocated this object or whatever, right? Like it's it's pretty indirect. And so, and you don't typically have a hold of pointers in the like memory address sense of it, like you do in C or something, right? So it's challenging.
Nice.
I would love to see this integrated into PyCharm and VS Code.
Yeah.
Right now it just gives you cool. It gives you like a cool tabular text output or file output. But if you could just right click in PyCharm and say analyze with Scalene, that'd be sweet.
Yeah, I wonder, and that would solve some of the install thing. So if you have to install it separately, something integration with PyCharm VS Code would be cool.
Right, like right now you can do profiling and it's really awesome in PyCharm, but I'm pretty sure it uses C profile. So yeah, who knows? Thank you for watching this segment of the Python Bytes podcast. This video was made during the recording of the full episode. Visit pythonbytes.fm and get the whole story. Subscribe to the podcast and get the entire episode delivered to your phone. Please support our work by taking one of the courses at pythonbytes.fm/courses or learning PyTest with Brian's book at pythonbytes.fm/PyTest. Finally, visit our sponsor shown on the screen here. Visit the link on the screen and get the special offer for Python Bytes and YouTube listeners. Thanks, and have a great rest of your day.